Hello, sir. How are you?
Good, I'm good. Thanks, Aryan. Good to be on this Samvad.
Thank you for coming, sir. And I been always wanting to have someone from the aerospace industry, engineering department to have a conversation because a lot of exciting things are happening in this space, literally. So first, let's start with the introduction. Can you just, for our viewers, just tell what your position is in IISc and what you are trying to do here research-wise?
Sure. Okay, so I'm an assistant professor in the aerospace engineering department here at IISc. So my research interests and expertise broadly are in fluid dynamics, aerodynamics, turbulence. So we do a lot of experiments in my lab and then theory associated with it. And then the other important part of my job here is to teach, train students. So next generation of aerospace engineers and scientists.
Pardon my ignorance. What is fluid
dynamics? Okay. So this is, when you have any kind of fluid, so fluid can be a gas or a liquid, right? So the air around us, right? So fluids move. Even a small child with the experience of the world around him knows that fluids move easily.
Yeah.
So fluid motion is actually very complicated, and fluid motion, plays very important. It's a very important aspect that governs life, the world around us, the universe. Right? Fluid dynamics is everywhere, right from how things move inside your body, in the scale of cells and even smaller scale objects, all the way to how matter moves inside stars. So anytime you have motion of fluid or matter, so there is dynamics involved, and typically it's very complicated. So that is very broadly, what I'm interested in terms of research, and more specifically aerodynamics. So that is, motion of air around objects. Again, the overarching motivation there is we want to fly. We want to fly fast. We want to fly high. Sometimes we want to fly out of the atmosphere, get into space, and things like that. So you need to understand how air moves around objects, and then how you can engineer your objects or flight vehicles so that you can make them fly more effectively, efficiently, and achieve certain engineering goals. And turbulence sort of comes everywhere because whenever fluid moves, from your daily experience, generally the motion is very chaotic. So that is very loosely, that is what turbulence is. It's a very important facet of fluid dynamics. So that comes, that's one of the major areas of our research interest here as well.
Okay.
A long answer.
No, it's okay. So basically, what I'm getting, and I saw your profile, you did BTech in aerospace engineering, then masters in space engineering, and then you went to aeronautics.
Yeah.
So within this earth, then outside, and then
outside.
back.
Yeah. So I've been dancing between aeronautics and space, but there are a lot of common threads.
Yeah.
As a kid growing up, I was always fascinated by human engineered flight. Even to this day, I'm very fascinated by human engineered flight, be it in the atmosphere or beyond. So I've been lucky to be able to pursue that interest.
Some of your work is in hypersonics, right?
Yes.
This is one area where we are trying to develop technologies to move faster on the surface of Earth, where we can travel at within hours. We can reach from say India to US or one part of globe to another.
Right.
So that will be a major breakthrough if it happens. Concorde was one example where it was moving really fast. But what are the challenges when you're researching on this thing? What are the challenges? You talk about fluid dynamics. So when the aircraft is moving at very high speeds, and it also depends on the structure, right? So when it is moving, aerodynamics come into play. The resistance also comes into play. The atmosphere pressure. A lot of things, climate, there are a lot of changes that are going on. So what is the basic engineering challenge here? Is it economical? Is it technological? What exactly are we facing? Why we are not able to develop commercial jets that are very fast?
Okay, so there are a lot of questions. There are a lot of sub questions.
Sorry about that.
No, let me try and unpack. So hypersonics is definitely an area of great personal interest for me, personal professional interest, and there's also a lot of interest at the national and international level in the area of hypersonics. So I would say that hypersonics sort of today it represents the cutting edge of aerospace engineering, and in many ways sustained hypersonic flight in the atmosphere is more challenging than say putting something into orbit. So this is so to speak harder than even rocket science.
Yeah.
It is, the possibilities are very enticing, and that one of the grand challenge problems that drive my research and my efforts is a very simple question. So we are sitting here in Bengaluru. Can we travel from here to say Delhi in 20 minutes, 15 minutes, 20 minutes, right? I think the answer is yes, and that is one of those things that pushes us to work towards realizing technologies like that. So here we are now talking about flying at Mach 6 or Mach 8 or Mach 10 through the atmosphere. So when I say Mach 6, that is traveling 6 times the speed of sound. So Mach 1 is the speed of sound, and anything above you're basically traveling very fast through the atmosphere. Yeah. So as one can imagine, this is not a trivial thing to achieve. It's interesting that you brought up Concorde, which used to do these routine flights with civilian passengers at Mach 2, slightly above Mach 2. So Concorde for me is a very interesting example because it represents one of those rare instances in sort of evolution of technology, if I may, where we've sort of taken a back step. So if you think about it, I mean, you don't find many such examples. If you think about it, 40, 50 years ago, you could actually, as a civilian, if you had the money, of course, it was expensive, you could, at least there was a possibility for you to buy a ticket, get on one of these aircrafts and fly supersonic and go to New York, London in 3.5 hours, right? Or, wherever that they operated Concorde. But today, you cannot do that, even if you have the money. So it's one of those very interesting
otherwise
scenarios.
It has been just the forward march of progress development,
right? Generally, right? I mean, if you see any kind of technology where things you will be able to do things faster or go faster or do things better, more efficient. But it's one of those rare instances where, and the reasons for it are a mix of technological reasons and economic reasons. Sure, I mean, there was technology, we have technology to fly fast, supersonic, right? But it comes with its own challenges, and at some point it was just not economically feasible to operate something like the Concorde with the technology that existed at that time to fly supersonic. But again, there's a lot of interest from commercial operators to see if not only supersonic, there are companies that are seriously exploring hypersonic civilian transport. So, fly Mach 5, Mach 6. Somebody can buy
hypersonics at that speed, it's like even aircrafts, we don't have like fighter jets.
Right.
I mean, we have
So fighter jets are typically, they have supersonic capabilities. Like for our own Tejas, for example, it can go supersonic, Mach 2-ish, maybe slightly more. Even the Rafale that we bought from the French. So this is supersonic. So when you get to hypersonic, again, there's for defense applications, you probably there's no good reason to put a man on a hypersonic platform. Tom Cruise goes Mach 10, but that's a movie. But a hypersonic defense flight platform will be unmanned, right? Whereas there is, I think, opportunity for civilians, as a commercial operation to fly very fast, supersonic, beyond supersonic, hypersonic. So coming to your earlier question about the engineering challenges, there are many engineering challenges, right? So one is aerodynamics. So you want to be able to design this hypersonic aircraft so that you have to operate very efficiently. So going this fast, as you can imagine, requires a lot of power. So you need to cut down every little bit of aerodynamic drag or resistance for you to be able to travel so fast through the air. And then there is the engine to power something like that. So hypersonic aircrafts are powered by what are called scramjet engines. So these are very interesting because the engine, if you look at a scramjet engine, it's on the face of it looks very simple because it actually has no moving parts within it. So compared to a regular gas turbine engine that you see on an aircraft that you flew, say, from Delhi to Bengaluru, it has this large fan and it's a very complex machine. So compared to that, a scramjet engine is essentially a duct with no moving parts. But that, on the face of it looks very simple, but it's extremely complex because you have to basically, combust fuel and generate thrust at those speeds. It's a very
overcome the resistance.
It's a highly challenging task to design these engines and have them operate in a robust manner. So that is a big technological challenge. And definitely you mentioned structures. So you need materials and structures that can handle the loads and the temperatures to offer you hypersonic flight, especially in a sustained manner, right? At the end of the day, if you want to have a commercial operation, you need a platform where you can just take off, land, and then
does weight also come into play because fighter jets are usually not that heavy. When you are taking passengers, it has to be large.
Yeah, so this will be if one were to imagine a commercially operated hypersonic aircraft, it would be larger than a fighter jet for sure. But then everything gets upscaled, so the engines also will be larger. So it will be heavier for sure. So and engines will be larger. The airframe will have a larger area to give you the lift.
Are you saying with the current technology that we are using, fuel? We are burning gas or fuel, right? But what is that power that can generate that kind of thing that takes you through that speed at that? Is there a possibility that we can do this, or we can see electric engines, or I don't know, nuclear powered engines?
Nuclear would be very risky. Nuclear would be very risky. Like I would be very nervous to put a nuclear power plant on an aircraft because the reason is sort of obvious. If God forbid there was a crash, then just the nuclear contamination risk it makes it a non-starter. But we can see a scramjet engine. You burn any regular, like you can design a scramjet engine to burn aviation grade, just kerosene, aviation grade kerosene, right? So you can use hydrocarbon based fuel. So the fuel per se is not the showstopper or not the real challenge for a scramjet engine. It is how you design your combustor. Like how can you how do you design the system where you're combusting the fuel and generating thrust? Because what happens in the scramjet engine is you're traveling very fast, say at Mach 6. So your engine is taking in this very high speed stream of air, right? And in a scramjet engine, the air doesn't slow down very much. So it basically passes through your engine at very high speeds, right? It comes in hypersonic, slows down a bit to supersonic speeds, and then gets out. So in this supersonic stream, you now have to inject, say, kerosene and get it to mix and then ignite it and get that flame to stabilize and generate, you'll generate hot gases, which you have to expand through a nozzle and generate thrust. So designing that engine is a very, very challenging task. So there's a lot of fundamental science involved, and then the scientific understanding of the various processes that happen, the fluid dynamics, the chemistry, the combustion, then allow you to design a solution that is feasible in terms of engineering a practical device, a practical engine.
But it's very much a possibility. Success is a very big possibility.
Yes. Great example is HSTDV. So the hypersonic technology demonstrator vehicle that DRDO successfully flew in September 2020, if I remember correctly. So they demonstrated this. I mean, other countries have also demonstrated scramjet engines. So India is also now in that sort of elite club.
So how much was the speed at which it was traveling?
So HSTDV, they flew a vehicle for 20 seconds. So it was a demonstrator. So they flew at Mach 6 for 20 seconds, powered by a Scramjet engine.
Wow.
So that is, see, 20 seconds at Mach 6 is a lot of time, right? So that was, that was a big milestone, I would say, in India. And now, I mean, there are extensions of that program where we are trying to fly for much longer duration.
So are there any learnings from the space sector? For example, in rocketry, that we see a lot of development is happening. For example, SpaceX is leading the innovation in that space. So are there any innovation that are happening? For example, Falcon engine is there, Raptor is there. So they are developing a lot of things like engine wise. And I'm sure there are some developments in the technology of fuel burning also, how they are innovating. So can those things be applied in aeronautics?
As in for Scramjets, let's say?
Yeah, or any other like technology to move faster at that speed, hypersonics. So can those technology that are being developed for space sector, can they be used somewhere here, whether it is heat resistance and other things?
Yeah. So to some extent, yes. See, some of the subsystems or some of the say the scientific know-how. For example, even in a rocket engine, you're mixing a fuel and an oxidizer and combusting it, right? So the whole the chemistry of combustion and the process, the fluid dynamics. There's a lot. I mean, this is essentially fluid dynamics. So the fuel and oxidizer have to mix efficiently and combust in a short time. So some of that scientific understanding that you get from, say, working on one problem, some of it will also translate to a related problem. But here the combustion setting is different in a scramjet engine versus a rocket engine. So there are differences, but some of the fundamental aspects, the scientific aspects, there is a lot of commonality. But the end technology will be different.
Okay.
Right. So yes and no. So there are things that translate between, say, these verticals. We want to call them different technology verticals. Some things don't. Some things are more specialized. And it's interesting. You also talk about materials. Yes. So high temperature materials is one of the developing high temperature materials is one of the big challenges today. It's one of the foremost challenges in hypersonics. Yeah. So any advancement in material technology that say happens in the design of a space vehicle there's a good chance that it can benefit.
That is where the biggest scope is, I think.
Right, one of the areas. Yeah. And cooling technology. So for example, even in rocket engines, I mean, things get very hot, so things are actively cooled. So heat transfer. So there's a lot of fundamental physics that one has to understand to be able to design a good system. So if you crack some of those challenges in one setting, some of those ideas can get translated, or it gives you newer ideas. Oh, this works for this reason, so maybe here we can try something else, because now you're sort of making an educated guess based on your experience with.
Okay, let's talk specifically about SpaceX, because a lot of things are happening there, and you keep writing about what they are developing. I have a very stupid question that is related to this, but I won't ask. I will ask you
after the cameras
are off. Basically, just let me ask, because they are building reusable rockets.
Right.
So they are sending the rockets outside the space, and rather than the lower Earth orbit, going into space, I think, is easier for rockets, because there is no resistance outside in the environment, right? Like in lower Earth orbit, you have to go into stage 2 and other things. But let's say you go into space, and then from India you launch and then maybe land in US. Will that be possible through rocketry? Because spaceship is coming, right? They are building spaceship.
Yeah.
So they are building, of course, for space travel, like going to Mars or something. But it can not exact technology, but similar technology. Can it be used on the space also?
Okay. So you started by saying this is a stupid question, but you're fooling your audience because you've packed in a lot of interesting things in that question. So again, let me try to unpack it. So I think when let me start with the latter part of your question. So when you say, can we say take off from India, go into space and land in the US? That's certainly a possibility. So this is what you call a suborbital flight. So you don't actually, in fact, it's easier not to get into an orbit. You don't want to entirely go into space.
That is difficult.
Right.
Like energy-wise, it's not efficient.
Exactly. So some of these ideas with these, hypersonic planes, so to speak, for longer distance is exactly this suborbital flight. So for relatively shorter distances like Bengaluru, Delhi, you will probably not actually get into these suborbital sort of trajectories. But India US is a good example where you can actually do think of a system that gets into a suborbital trajectory and lands. So that's certainly an area where people are thinking very, not just thinking, trying to do things seriously.
So some things are happening on that.
Some things are happening on that.
And I thought I came up with this idea.
Yeah, you're just fooling your viewers. Okay, so the other part of your question is, getting into space. So getting into low Earth orbit is easier than higher orbit. So you can think of it this way again, your high school physics. So the further away you have to go from the Earth's surface, the more, your gravitational potential sort of increases, so to speak, right? So you can imagine you have to expend more energy to get there. So low Earth orbit is easier to achieve than say geostationary orbit, or if you want to completely escape the Earth's gravitational field, like if you want to launch something, say, towards Mars, so that takes more effort. So the effort sort of goes with how far you want to go away from the Earth's surface.
Yeah.
So what SpaceX is doing with these reusable, completely reusable rocket configuration, it's actually a paradigm shift. I mean, what they've done, if you think about it, it was science fiction until about 5 years back. I mean, if you look at some of these old cartoons and, maybe even movies from 50s, 60s. So they had these kind of configurations where you'd see like rockets will use their retro propulsion and land back. I mean, this was really sci-fi.
Yeah.
And again, in terms of the engineering involved to bring a rocket back with its and make it land like SpaceX does, it is a very, very challenging
It's
thing.
Crazy how those arms spread and they just catch the...
Right. Just how do you fire the engines, how do you control the rocket and carefully bring it back? And the fact that SpaceX had failed so many times, and there's so many videos of their landing going wrong when they're doing the development, right? I mean, these are great internet memes.
Yeah.
Right? That also tells you that this is not an easy thing to do. But now that, they have figured out how to do this consistently, and they have basically cracked this technology, and now this is a paradigm shift, because this is fundamentally game changing, because it drastically brings down cost of access to space.
Yeah, like Elon Musk gave an example that imagine you had to buy a car every time you wanted to travel from one place to another.
Right.
So imagine how stupid that will be.
Right.
And much costlier, and you wouldn't even use half of the time. But it becomes reusable.
Right.
So lot of things, the possibilities,
right,
they're endless.
They're endless.
Yeah.
But it is sort of, I mean, this is evolution of technology, right? So when when Goddard and all these scientists started building rockets in 30s, 40s, 50s, I mean, just the fact that you could get into space was a big deal, right? I mean, that was, thinking about reusing rockets at that time was way too premature. So this is sort of natural evolution of technology from those years and decades. And then you got to a point where, then launching rockets was a very routine affair, at least for those countries that were in the space club, including India, right?
Yeah.
So then now what next? Right? Launching rockets was a routine affair, but it's still an expensive affair. I mean, by no means cheap. So then this is sort of the natural evolution. So that now you're pushing the technology so that you can, not only is it routine, but now you can actually do it at a much lower cost. So you can do it much more often, and you can now think of using it for many more things, many other things, many more ambitious things than you could previously, just because of the price tag.
Yeah, I mean, the fraction of a mission. A huge portion of that is in rockets, and if you can reuse it, the cost is drastically reduced.
Yes.
And another important factor is like going to Mars. So that is also like if you can go and refuel, for example, an aircraft midway, not aircraft but rocket.
Right.
So imagine like you can do it 2-3 times and it will reach.
Exactly.
So that is also become easier.
Yeah, exactly. So essentially with this, with this entirely reusable configurations, you've basically made a rocket like in some sense an aircraft, right?
Yeah.
So an aircraft, you fuel up, take off, you land, fuel up again, take off, land, and you can do that sort of indefinitely almost with some maintenance cycles in between until the lifetime of the aircraft.
Yeah.
So you can now do that with rockets, and that's a very good example where you're thinking now very ambitious in terms of getting to Mars or beyond. You almost have to rely. You can only do things like that with a reusable configuration because you can fuel up and it just makes it really expands the possibilities of what you can do in terms of going much beyond Earth's orbits.
Yeah, which is not possible in say 2-stage configuration.
Right. Or the things that payloads that you could get up to Mars would be very, very small.
Exactly.
Right. Your rocket sitting on the launch pad will be several hundreds or even 1,000 tons.
The SpaceX, what do they call it? Spaceship or something else? Starship.
Yeah.
So I think that has the ability to take 150 tons or something.
Yeah.
So it's crazy.
So not only that, so it's the thing is following. So if you didn't have a reusable configuration on each launch, you only take for any rocket launch, whether it's reusable or not, the fraction of your payload, that is ultimately what you're putting into orbit or on some other surface like Moon or Mars, is only going to be a very small fraction of the total lift-off launch. I mean that because you just will majority of the weight there is your fuel. Like you have to burn off that fuel and your structural weight, right? So because you need that amount of energy to escape the Earth's gravitational potential.
And then also you have to just push against yourself because there is no other Newton's third law. Like there is no in space, it's space, so nothing is there. So you have to push against yourself. So you have to keep burning.
No, so it's not so much. It's about once you're in space, there is no resistance. So it's basically inertia. If you're traveling at a certain speed,
it will keep going.
You're going. If you're going along a straight line, you will just maintain your speed. Or if you're along some sort of an orbital trajectory, you will maintain that orbit. But to think of it like a slingshot, right? To get from here to Mars, you need a very high initial
thrust and
So once you're in that transfer orbit to Mars, then you're on your way. But to get that initial thing, you have to burn enormous amount of fuel. Right. So now what the reusable configuration does is it allows you to basically have refueling stations. You can have just like fighter jets refuel from a fuel tanker. You would have seen right. So it is basically the same thing that is now possible because you have this reusable rocket which can sort of go up and down many times for not, relatively speaking, not a very large price tag. So you can set up a fueling station in orbit. You can set up a fueling station on the moon, where you go. You do multiple launches, fill up a large volume of fuel. And then finally you launch your ambitious thing to Mars. So initially it gets off into orbit. To get into the Earth's orbit, it is burning some fuel, but it will then refuel. Now it's again on a full tank, so it can go to Mars, and then maybe you've already set up some fueling stations there, so you can it just becomes like our petrol bunks. I mean, this is sort of it's still sort of bordering on sci-fi at this point, but we might see this in our lifetime, and that is really the
not
exciting
just in lifetime. I think in 5 to 10 years we can see significant developments. And what do you think about the engines they are developing, like innovating in the engine space? How much significant that part is?
So
Raptor, Falcon.
Right. So they're making things more efficient. So fundamentally, they're not doing anything completely new. I mean, this is just the good old rocket engine, right? Where you take fuel, like I said earlier, you take oxygen, mix it, burn, right? So fundamentally, it's the same concept. So for instance, the Scramjet is conceptually very different, right? But in terms of rocket engines, what SpaceX is doing fundamentally is nothing different from what people have been doing since 50s, 60s. Started using liquid rocket engines, but they're doing things much more efficiently, right? Like for the same thrust or force that the engine produces, the engine weight is now lower, or for a given weight, it can give higher thrust. Because now we have better materials, better way to control things. So it's just they refine the heck out of the engine. So that way, it is just like your IC engine, right? So unless you're driving an electric car,
improvement over previous ones, right. Not a drastically new.
Right. So the petrol engine of today conceptually is the same petrol engine that was there in Ford's.
Yeah.
Original car conceptually. But if you look at a simple metric is the mileage.
Yeah. Which nobody can beat Maruti in.
Yes. Whereas now electric car is a paradigm shift.
Yeah, that is the difference basically. So much is happening, like a private company in US is doing so much innovation in this space. I mean, better than NASA in some areas. So where do we stand? Like after this Chandrayaan thing, Vikram lander that failed, a lot of people have started doubting it. I'm sure like failures are a part of any mission. But Gaganyaan, for example, was supposed to go in 2022. Then everything gets blamed on COVID. But so
yeah,
let's be like, what is the problem? Like, what are I don't want to get into like what went wrong or anything, but I mean, I'm sure there are genuine reasons also. It's not, sometimes we try to be ambitious too much, given our capabilities. And I'm sure in Gaganyaan, we are doing everything from scratch. Too much indigenization is happening there. So, but rather than talking about that, I want to see like, where are we in this current state of things? The way world is progressing, the other countries are moving forward. A private company is doing so good. So yeah, where are we? Where is ISRO?
Again, this is a loaded question. I will unpack. So in terms of, space is tough, right? There's no shortcuts. There are no easy ways. Every spacefaring country has had their share of lessons learned the hard way.
Yeah.
Right. So the Chandrayaan thing is a setback, sure, but you learn from it. I mean, this is part of the business. It's of course disappointing when things don't work out, but this is part. It is.
But these things are bound to happen.
These things are bound to happen. So I personally wouldn't. I don't think of it as a major setback at all.
Yeah.
Right. So and soon, I mean, we are going to try again.
I mean, actually, that is not the way to look at
any
mission. Like if you fail, you learn from it.
That is actually SpaceX's whole mantra. If you
fail faster.
Yeah. Yeah. The more you fail, the more you learn, and the earlier you fail,
Yeah, people still like even when they try to like combust this thing in space on deliberately, people cheer up like, yeah, good.
Right.
Like they failed again. No, they didn't.
Yeah. So embracing failure is, of course, see, you design things to the best of your ability. It's not that people are willingly failing, but these are very complex systems. So there are literally a million things that can go wrong on these systems.
That's why it's called rocket science.
Yeah. So when you fail, you learn, right? So not that people are stupid. I mean, there are very smart people at ISRO, SpaceX, all of these places, right? It's just that it's part of business. So if you take the US, you just look at their journey in space. They've had a lot of failures and they've learned along the way. It's just that, their failures, they've been through this learning curve. It's just that their failures happened at a time when there was, or majority of the big failures happened at a time when there was no internet and definitely no social media and not this much scrutiny. right? So ISRO is sort of along that curve, but catching up very quickly. So be it Chandrayaan or any other ambitious thing that they're trying, maybe they fail on their first attempt. Lessons learned, they'll get it right sooner rather than later. So it's part of the business. Now, private enterprise in space is actually a very I would say very exciting prospect, because sort of Elon Musk is of course the poster boy for this, and he has shown what is possible. And I think again this is sort of in some sense natural evolution, I would say. So either Elon Musk or combination of Elon Musk and other factors. Clearly, our government has taken a big cue from it. So now there is definitely a very strong push to open up. I mean, not just push. I mean, formally the government has opened up space in a very liberal way to all kinds of private enterprise. So I think this opens up a lot of possibilities. I'm very bullish on space technology, particularly for India. So if we can manage to have consistent policy in terms of who can participate in space and in what way, and the government policies are consistent. I mean, consistency is important, right? So for 5, 10, 15, through several decades, I think it is going to pay off in a big way in terms of technology as well as economically. So I'm quite bullish on the prospects.
So interestingly, you talk about there was not so much scrutiny at the time when US was trying all these things and failing. But as a result of it, like after Apollo missions, like it's been 50 years since we attempted another manned mission to moon. So I mean, they're trying again, but it's 50 years. So at least some failure had some impact. Like you are spending so much money, and I think it was there in 1980s. They estimated that it will cost around $500 billion or something, and then Congress didn't approve the budget. So the whole thing was disowned, and then they went for Hubble telescope. That has proved to be a huge thing. But it has some impact. Like failures do have an impact because it costs a lot of money, and when they fail, like there is definitely a setback. So 50 years since we went back to moon, and that's the reason why people say, like there is a meme also, like our phone discharges in 3-4 hours, 5 hours, 6 hours, but we apparently landed on moon 50 years back. So where did that technology progress go? So it's like Concorde, right? So you talked about that. So it's a back flip kind of going back on the progress side. So we had such fast moving commercial jets. Now we are not having that for the last 20 years almost. So how do you like see this? Why we have not been able to go? I mean, one is definitely the funding thing, but is there like nothing to, like what is the cost benefit ratio? People also look into that. Like, ठीक है, एक बार चले गए, झंडा गाड़ दिया, उसके बाद क्या? Like what to do? Is there a lot of things to be done there, and is the cost a challenge, or is the technology a challenge? Because just going back again and not doing anything is it's what you say, it's a like kind of trivial thing. Like already somebody has done it already, so why you go back again and do the same thing? You want to do something extra, right? You want to build structures there, you want to stay there for longer. So please, I'm blabbering a lot of things, so you feel free to unpack now.
What
is the reason?
This is false humility, because you're asking a lot of interesting and relevant and loaded questions, but saying these are stupid and blabbering. Okay. So firstly, let me start off by saying, for people who are complaining that their phone, like the phone that they have in their hands today, or any of us have, has way more computing power than the computers that took humans to. It's just that, we don't appreciate how much technology we carry with us, and how we take it for granted, how rapidly it has evolved. So it always helps us to just take a step back and see how things were even when we were kids. Okay, so now coming to your question. So so when I said there was no scrutiny, it's not that that infinite resources, you could do whatever you want. It's just that the scrutiny was of a different kind. Maybe it was better way to say it was probably all behind closed doors for the most part, or relatively speaking. Right now with social media and hyper connected, and you get videos of everything everywhere. Everybody is an expert. Right? So it's different. It's different kind of scrutiny now. So when US went to the moon, the mahal around, like at that time, the geopolitical mahal was also very different. I mean, this was the peak of the Cold War. Right? You should now think in terms of where the Americans were. So the Russians at that point had beaten them to putting a human in space. Right? So there was a lot of Cold War pressure on them to do something big, and sort of this was a very important. It was a technological war and a psychological war. Yeah. Right? It was.
The country was also going through a lot of things.
Right.
Vietnam War and
correct.
all those.
So in fact, it's funny you bring up Vietnam, because Vietnam was the thing that actually in many ways it killed the Apollo program.
Exactly.
Right?
Because so much.
Right? Because so they were under a lot of pressure after. So there was Sputnik, where USSR managed to put the first man-made object into Earth's orbit, which was something extraordinary sci-fi stuff at the time.
Yeah.
And then they sent Yuri Gagarin, and this was they were the two USSR 2, USA 0 school, and so they had to do and at that point, I think if I remember my history correctly, so Kennedy had a bunch of political setbacks. So there was a lot of pressure on him to do something extravagant that he'll be remembered for, and I suppose he was successful. We people in pop culture, is associated with Kennedy's push to put people on the moon. So it was a very different era. So they had to get to the moon. No, they would not spare any means, right? So what that means is that the technology that they were developing, they were not really looking for efficient or the best performance, or definitely not reusability. Cost was also not a primary thing. Right? So there were a lot of that Apollo aero technology. It works, but it's not the best. Right? Well, it's not the best way to do things.
Prestige on the lines.
Right. So they just wanted something reliable and it works. Yeah. Right? But it was not refined. It was not.
And record it in a studio in Hollywood after coming back.
Yeah.
Okay.
So that's if they did that, that's only then we are talking a very tiny fraction of the cost of the. Yeah. I don't buy any of that.
Yeah.
So they went to the moon. They got there. They were able to show that they could go back repeatedly, and it was all the Apollo missions were over a span of roughly under 4 years, right?
Yeah.
So they made their point, and then they realized it was getting expensive to keep doing it. It's a very expensive affair to get to the moon, especially with technology of that era. And then towards the end of the Apollo missions, that's when they were now facing the heat of the Vietnam adventures, right? So then it got tough, and then they shelved the program.
73, I think, was the last one.
70, or maybe even 72. Yeah, 72, 73.
73, yeah. Last Apollo mission.
Right. Yeah. So it was really, if you were to think of it, it was really again the economics that sort of put a stop to the whole thing, right? Because it was just.
I think they put a stop. Then Reagan came and he was like, "Let's do it again." And then that 86 incident that happened, where he gave that famous speech, like, touch the face of God. I think that was really a big setback. 86.
Yeah, but again, see, because they never went back though, right? See, that was at 72, 73. That was the end of it. And these are also, these are very complex missions to execute it. It's not that, if a president signs off.
But it's a good thing, right? If you don't make it an ego issue.
Right. No, but I mean, it hardly ever is not, right? So the thing is, it's not, see, they stopped the Apollo programs, and, it's not easy to just revamp something out of thin air. It's not just, presidential order and then you fly the next day, right? And also it becomes very political, because a lot of these, almost every president or prime minister, they are very conscious about their legacy. So they want things that happen during their lifetime, or particularly when they are going to be in office.
Announcement and the execution happens in the same term.
Right. So it see, things like Apollo, they get caught up in these kind of political calculus. See, even Kennedy, by the time these guys landed in 69, he was no longer even alive. I mean,
long gone.
Yeah, even if you're alive, he would not be president, because I think he would have finished off his 2 terms. Right. So these are calculations that are, important. I mean, I'm not justifying them, but the reality is they figure in the final. I mean, they are a big factor in the final decision making. So that, I mean, it doesn't help if you don't acknowledge that.
Yeah. Now, coming back to the ISRO, like what they are trying to do, the Indian government has come up with a new policy, which basically one of the features is that it wants the private sector to take a lead in space sector. So what do you think about that aspect? Like, people are already saying that we might see an emergence of new SpaceX-like company in India. But even if that doesn't happen, there are many things that private companies can do, and that can help ISRO also innovate or do missions faster.
Okay, so what if I were to sort of condense the new space policy, what this government really wants is definitely they want the space sector is now fully open. If you have the money and you have the ideas, you can do whatever you want in space, pretty much, right? On sound ideas. If you have a sound idea, you can go ahead. The
Even
government
if you
will
don't
not
have sound idea, like you want to make the rocket more pointy.
No, in the sense, I'll tell you.
Like
I'll tell you why I say sound idea. So, space is also a risky, dangerous business. So, if you are a private enterprise and you say you want to launch something which is not designed on sound principles, now your rocket or whatever should not end up taking out satellites or causing or crashing somewhere and killing people. So that's what I mean by sound. So there are checks, and this is exactly where in space.
I'm just pointing out to the Elon Musk thing where he said that I wanted to, inspired by that movie, he wanted to make the rocket more pointy, which is worse than a roundy kind of thing.
Yeah.
So only a maverick like that can do
right.
this
So
thing.
that is,
but that is what allows you to do in private.
Yeah. So that is showmanship. I mean, to some extent, that is okay. I mean, it's fine. It's good fun. But on a more serious note, so what I say when sound principles is now the government or the in-space role is to essentially ensure that what you're putting out into space is reasonably safe. I mean, there's no 100% guarantees. Things fail, things can fail, but at least on the face of it, when an expert looks at it, they should say, okay, this is designed on sound principles, so it's fine. You can launch, right, or you can put something into orbit. So the role of the government is now going to be pretty much just that you are a private enterprise, you have capital, you want to launch something, you want to put something in orbit, you want to do remote sensing, or you want to be even more ambitious, you want to go pluck a asteroid out of its natural orbit and bring it back to Earth because maybe it contains some rare earth metals, minerals, whatever, right? Some value. The government of India will support you.
Okay.
So this is actually, again, I would say a paradigm shift in our thinking and way we've been doing things in India. Because until very recently, space has been sort of an exclusive domain of the government
Absolutely.
in this country, right? So only the government did things in space, like with taxpayer money. And by any measure, I would say we've been very successful at it. But now things are changing. So we are no longer the India that we were in 50s, 60s when we started getting into space. So now we can dream big, right? We are much more ambitious. So this is where, private sector participation comes in. So the way government is now thinking of ISRO, in fact, not just thinking, even formally, if you see the new space policy and the way they are structuring things in the Department of Space, ISRO is just going to be like any other entity, any other spaces entity, right? So just like, you have ISRO and maybe there are 4 big companies that can also launch, and so they're all now going to get equal treatment.
Okay.
Right. So that is sort of the vision, that you have many companies and ISRO is just government's enterprise in that. Right. So a very loose analogy would be like, we have, Airtel, Jio, Vodafone, whatever, and there's also BSNL. So as a customer, you choose. It becomes in some sense a free market. So ISRO will continue to have its niche. In fact, the government is now encouraging ISRO to do more high-end research, right? Like focus more on pushing the technology envelope rather than doing slightly, the things that are more routine, which they have mastered and they're done. For example, the PSLV, it's a workhorse, right? Yeah. But that is technology that ISRO has now mastered. I mean, they've launched successfully over 50 times, and it's a very reputable launch vehicle. It's reliable. So ISRO shouldn't be spending more of its time and resources in doing more PSLV launches. Just let a private enterprise handle that. You focus your energy and resources on now pushing the envelope of technology, right? So that is sort of one of the key drivers. And then once you open it up to private enterprise, ultimately it's the economics that dictates whether it's a success or failure. And there's huge economic potential in space. So the government wants to now harness it, and I mean that is the right path forward, I think. It's certainly very exciting in terms of the possibilities.
Another thing that Elon Musk has done is the internet from space. I forgot the company. Starlink. So it came in very handy in Ukraine, for example. Yeah. I have been wondering since I heard this, that we are expert in launching satellites into space, like more than 100 satellites we launched in one go. So why can't we have, like ISRO have its own Starlink kind of thing? Because as we know from the experience, relying on foreign companies is not the way to go. It's kind of sovereignty thing also.
Right.
Like it can be used as a geopolitical tool, for example, in Ukraine.
Yeah.
So like why don't we do it? It should be easy to do, right?
Yeah. I mean, easy is a relative thing. So in theory, ISRO can do something like the Starlink, but now it's just about priorities, because see, ISRO works with its own given finite resources, right? Be it in terms of money or the number of people they have working on a certain project at any given time. So you have to have priorities, because ISRO already has so many things lined up. Probably something like the Starlink is not figured in the priorities yet. But now there is nothing stopping a private enterprise in India from doing a Desi Starlink. Right? I mean, I think that is actually more sort of more enticing prospect, if you ask me.
I think if we can just, in my opinion, it's nothing to do with you, but I think the amount of money we spend on BSNL, if we just put it on Desi Starlink, and imagine like they give this national asset thing and remote areas, it covers that, which no commercial this thing will go. That is the purpose Starlink serves, to remote areas.
Yeah. So it was I mean, yes and no, right? Because I mean, the bandwidths are going to be the kind of data bandwidths that you get in a cellular network is going to be different from what you can get from orbit.
So each can be a filler, not a
I think
alternative.
I think each thing has its place. I mean, not specific to BSNL as such. I mean, because you have Starlink, I don't, at least to the best of my understanding, it's not that you can get rid of cellular networks entirely, like ground-based. Yeah.
Wherever the gaps are, those can be fulfilled with very precision satellites.
Yes.
Covering those areas.
Yeah, you could. Yeah. So now the question is, will the government try to do something like this on taxpayer resource, or will a private enterprise want to? Because if you can make a good business model out of it, you can do it as a private enterprise and offer your services to the government if they want to just buy it from you to offer connectivity to more remote areas.
Yeah, I agree.
So which is the model that you want to go? Do you want an entirely government enterprise doing this, or do you just want to open it to the market and let okay, if you are a company that is going to give me a service like this and I'm the government, I would just buy it from you rather than do a PSU style.
It's just that it is related to something that can be a geopolitical thing.
Absolutely.
Yeah. That's why I am talking about the government aspect of it rather than private.
Again, see, there will be regulations, right? It's if you are a private company and you have something like this in India, it's not that now you can with your space assets you can go rogue and do things.
True.
So even in some of these things, even in the space policy, it is. I mean, these are clearly laid out. So, for instance, another example is the quality of remote sensing data. Right? If I remember the numbers correctly, so there is something called. So it's essentially like the resolution of your satellite images. Right? So you get digital images from your satellite. So if each pixel, say one pixel to other pixel on ground, if it represents certain amount of distance, right? The actual distance on the ground. So I think right now anything above 5 meters, if you're a private enterprise, you can just get that data and put it out. The government will not get in your way. But I think they have put a limit of, I think if it is below 30 centimeters, so high resolution data, even if you're a private enterprise, you cannot, the data might be yours, but you cannot just, sell it or do, sort of shady, nefarious things with it. The government will step in when there is security.
Yeah.
So they have to. See, there'll always be, sensible regulation, right? The idea is to do things in a way that benefits all, and you draw commercial economic value out of it, but you don't want any of these activity posing national security issues. So that I think the government is very well aware. There are enough people looking at these things.
Okay,
finally, nobody goes rogue.
Finally, like everybody sending their satellites and everything, and even Elon Musk sent his car there and it's roaming around.
But did he brought it back?
No, it's
still there.
Yeah, it's still there.
Okay.
So
he's polluting. He's one of the polluters.
Actually, it's on Mars orbit. Yeah, it's on Mars orbit.
No, he put it into
No, not
Earth's
in Leo. Not. It's on Mars.
It's in Earth. At least the videos I remember seeing, it was orbiting the Earth. I don't think
he put it on then Mars orbit.
He sent it out, is it?
Yeah, Mars orbit.
But I thought
the idea was like some alien somewhere, wherever.
No, but I thought the car was released, no? So it was freely orbiting the Earth, wasn't it? And how did he then again?
It was worked as a payload, basically. Okay. So the rocket, basically, instead of satellite, he sent his car.
That's true. But then I thought the car was released into orbit.
Yeah, orbit is rotating on its own.
But it was originally orbiting Earth, wasn't it?
Not Earth. I think it is on. They timed it such that transfer happened between Earth and Mars, I think.
Okay, I have to look at it because see, once you're in Earth's orbit, to send it to Mars again, you have to, like we discussed, you have to give that
another push.
Yeah. So the car was released in orbit. The only way to do it is you grab it back again onto your rocket and then. But okay, anyway, let's not get digressed.
Yeah. So I was saying like all these things are rotating, and the big worry is the space debris. So
yes,
there is this Klasner theory that is there, that if there is some collapse of materials, it will be filled with this debris. So how do you see this, all these things going into space and maybe something striking?
Yeah,
So
see that is a nightmare scenario, definitely, right? Like space debris is a big concern. So there are serious efforts internationally, even in India, to track existing debris, and you want to plan your orbits carefully so that you minimize chances of impact. Because if you think of it, even a tiny speck of dust, if it comes and it's a speck of dust that's in orbit and it impacts you, it carries tremendous amount of momentum. It can do significant damage. So it is a cause for concern. Again, I don't. There are no easy solutions to this. I mean, there are lot of concepts to conceptual sort of ideas, grand ideas to clear debris, right? Again, to the best of my knowledge, I don't know if there's anybody actively doing debris cleaning at this point. So
there is no scope that you just clean it.
No, because see, this you have to imagine. So this debris is spread over a huge volume. I mean, we are talking about
300-400 kilometers
orbit, and it's just, this a tiny thing, and there are like hundreds of thousands of these things, right? And they're spaced apart. Like it's not that you put a giant net, you can grab everything in one go. It's not that. It's not easy. It is a lot of hard work. So the least that you can do now moving forward is to be more conscious of this as you plan, as you design your payloads or launch vehicles, right? You don't want to add to the existing problems. You always want, if you're going to design something today, you get something into orbit, and at the end of its life cycle, you try to plan it such that you don't leave anything there. Just bring it back down. On the way down, it will just burn off. Right. So I think now this is sort of collective responsibility of everybody who's in this business, international at a global stage. That there should be some collective responsibility. You cannot. To some extent,
one nation cannot just take on this thing. It has
not just. Even when you do things, right? Don't.
Like you have to be selective in what you do. Like you just don't do it for the sake of doing. There's enough out there, so.
And just the way you design your systems and things should be done in a controlled way. Other example is a lot of times you have Chinese debris that does uncontrolled re-entry, and you don't know where it hits. This is not a good way to be doing things, and
that will be the end of our Chinese made things. Fantastic, sir.
Yes.
Got to learn a lot.
Thank you. I really enjoyed.
Thank you so much.
All these loaded questions in the guise of a layman, but definitely not.
Didn't do much research. Just whatever is.
No, but this is good. I want more people to talk about these things, think about these things, because I think
this is one sector that we have done very good.
You've done well, and I think aeronautics and space in general is very exciting, and I want especially the younger generation to get fascinated by this.
And I'm sure Gaganyaan, when it succeeds, it will do wonders for the next generation also, inspiring youngsters. I was looking at the YouTube comments in one of the Gaganyaan videos, and people were commenting, I'm 17 and I'm so inspired by this, 16, and like it's really good thing. So if it succeeds, it's going to be
yes, it is going to be one of those iconic moments in the history of our nation. So we all look forward to it and pray for its success.
And next time when you are in Delhi, we will just do it in proper studios.
In your studio, yes. I would love to talk more.
Because a lot of things are still need to be expanded on.
Oh yes,
we have just covered the surface.
Would be happy to do this again in your studio this time. And
thank you so much, sir.
Different setting from my office. Yes, thank you.
Great learning. Thank you.